Do you want to know?
Today we'll discuss regarding azimuthal quantum number. It is otherwise called as subsidiary quantum number, or it is called as angular quantum number. It is represented by the letter L. It depends upon principal quantum number L, right? Azimuthal quantum number. Or it is called as subsidiary quantum number. So whenever we are going to discuss regarding any quantum number, we have to focus on the 4 points. First one, we have to define it. Then how it is represented. Then what is its range? What are its significance? So first we have to define it. This azimuthal quantum number is defined. That means it only used to define the position of electron within a subcell that present in a cell. These are the integer. These are the integer which are used to define the position of electron within subcell that present in a cell. This is the different definitions of azimuthal quantum number. So it is represented by the letter small l. This is the representation. Its ranges l equal to 0 to n minus 1. That means this azimuthal quantum number or subsidiary quantum number, or it is called as angular quantum, that depends upon the value of n, principal quantum number, right? Then come to the significance. Means information. What information this azimuthal quantum number carries? We go for the significance. So significance of azimuthal quantum number. Significance of azimuthal quantum number. Significance. So first information, it identify first significance. It identify difference of cell. That present within a cell. Within cell, right? So whenever we understand this significance, we will understand this azimuthal quantum number. So it identifies different subcell that exist within a cell. So think of, suppose this is the first cell which is closer to the nucleus, called as K cell, where the principal quantum number n equal to 1. We have to find out, here is the nucleus, right? So we have to find out how many subcells these K cells have, right? Suppose entire campus is considered to be as, suppose the building or the houses you are now you are there, and you consider that complete building is considered to be atom, and different cells are there. Let it you are in the K cells. Information is given on the door. It is K cell. You are sitting with the K cells. By the principal quantum number n equal to 1. This labeling is given in your door. K cell and principal quantum number n equal to 1, and L ranges from 0 to 0 dot 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 n minus 1. This information is given on the door, the room where you are sitting. Right? We have to find out how many subcells these K cells have. The number of subcells within the K cells. So first cell, just write down cell principal quantum number. As it depends upon principal quantum, we have to write it. Principal quantum number, azimuthal quantum number, or we can write value of L and name of subcells. Name of subcell. Right? So cell, K cell, principal quantum number n equal to 1. So here the value of L, azimuthal quantum number, or the value of L. Azimuthal quantum number, or we can write value of L. So for K cell n equal to 1, so put 1 to get the value of L. So by putting 1 here, that means L equal to 0 dot 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 1 minus 1 means 0. So from 0 to 0 it is nothing. It is only 0. So L equal to 0. So L0 means it is a code address of a subcell at present within the K cells. And this code address is called as code address for a subcell. That means S subcells are present within the K cells. For example, like this. Suppose this is the cell closer to the nucleus. Right? K cell where the principal quantum number n equal to 1. So by putting this 1 within this value, we get L0. So L0 means there is no subcell within this cell, and it is only one subcell within this K cells. It is a confusing term. As L equal to 0 to n minus 1, that means 0 to 0 have no meaning. L equal to 0. It's a code address of a subcell. Already I have told. There is no subcell. How? And again, this L0 is a subcell. So it is confusing. How? So it will be convinced like this. Suppose the room where you are sitting, that is your bedroom. So when you are using for the purpose of sleeping, but the same room when you are using for the purpose of kitchen, that is called as kitchen room. So how many kitchen room you have? 1. How many bedroom you have? 1. So how many room total you have? 1. So when it is used for the purpose of a cell, its principal quantum number n equal to 1, it is called as K cell. When it is used as subcell, same cell, used as a subcell, then its azimuthal quantum number is L equal to 0, it is called as a subcell. K cell behave as a cell. At that time, principal quantum number n equal to 1, it is behave as a subcell. At that time, azimuthal quantum number L equal to 0. That means L equal to 0 is the code address of a subcell. L equal to 0 is the code address of a subcell, right? Similarly, go for the, it is better if you understand in second example, L cell. So we are going for the L cell. Principal quantum number n equal to 2. For L cell, suppose we are describing another cell here, right? This L cell where n equal to 2. We have to find out how many subcell this cell L cell have. Suppose you consider the room where you are sitting, that is considered as L cell, and just on the door it is labeling like this. It is L cell where the principal quantum number n equal to 2, and also this labeling L equal to 0 to n minus 1, that also mentioned within the door, on the door. Suppose you are entered into the room where this room name is L cell, where the principal quantum number n equal to 2 and the azimuthal quantum number L ranges from 0 to n minus 1. You are entering into that room. Before entering, you just labeling is given on the door, right? So our task is to find out how many subcell this L cell have, the room where you are sitting. So putting this value of n, principal quantum number here. So by putting 2 here, that means L equal to 0 dot dot dot. Here 2 minus 1. 2 minus 1 means 1. 0 to 1 mean, this implies 0 to 1, that mean L equal to 0, L equal to 1. That means the L cell have 2 subcells. This L cell have 2 subcells. One subcell name is L equal to 0, L equal to 0. Another subcell code address is L equal to 1. So the subcell which have L equal to 0, its name is A subcell, and the subcell which have code address L equal to 1, it is called as P subcell. So for L0 we can write it is A subcell. For L equal to 1 we can write it is P subcell. That means there are 2 subcells are present. There are 2 subcells are present within the cell 2. So when the principal quantum number n equal to 1, subcell will be 1, that is A subcell. When the principal quantum number n equal to 2, the subcell will be 2, that is L0 and L1. These are the code address of 2 subcell. For A subcell the code address is L0, for P subcell code address is L1. So there are 2 subcells present in the cell L cell where n equal to 2. Now just thinking about just another cell is here, right? Let it be another cell called as N cell. It is N cell where the principal quantum number n equal to 3. We have to find out how many subcells are present within this N cell, right? How many subcells are present within this N cell? So N cell where the principal quantum number n equal to 3. Just you think of the room where you are sitting, that room is called as N cell. The information is given on the door and you are sitting in the N cell where the principal quantum number n equal to 3. And the azimuthal quantum, the same information, azimuthal quantum number ranges from 0 to n minus 1. Same information is given the room where you are sitting. Just we have to find out how many subcells within your room. Just this information is given, n equal to 3. N cell, we are sitting in N cell where the n equal to 3. Azimuthal quantum depends upon the principal quantum number. So put 3 here. That means L equal to 0. L equal to 0 dot dot dot. Put 3 here. So 3 minus 1 means it will be 2. So 3 minus 1, 2. That means this implies You just watch it whether it is. Let me to write on the top, right? Same information was given. We are on the third cell where is n cell. Principal quantum number n equal to 3. Same information, L ranges from 0 to n minus 1, right? We are on the third cell. Second cell is over, we are on the third cell. So for third cell we will determine, suppose we are in third cell, n cell, n equal to 3, this is cell, principal quantum number, value of L, value of L or azimuthal quantum number. So L equal to 0 to n minus 1, that means 3 minus 1 will be 2. This indicates L 0 to 2 means L equal to 0, L equal to 1, L equal to 2. So that then it will be 0 to 2. So L0 is a code address of one subcell, that is called S subcell, and this L1 is a code address of B subcell, L2 is a code address of D subcell. So these are the subcell. Value, right? We can write range here also. So there are 3 subcells present within the third cell where the principal quantum number n equal to 3. The room where you are sitting, let it be 2 partitions will be there. One part, suppose whenever you are entering into the room, this labeling is mentioned, n cell, n equal to 3, L ranges from 0 to n minus 1. This information was given on highlighting information on the door, the room where you are sitting. And you are going to find out how many subcells, how many small rooms will be there. So by calculating, you get there are 3 small rooms where code address is L0, L1 and L2. SPD, there are 3 small rooms will be there. 2 partition, let it be 2 ply partition within that room. One room ply partition where mention L equal to 0, another L equal to 1, another L equal to 2. So there are 3 rooms available within the room n cell where the n equal to 3. That means n cell contains 3 subcells. There are 3 subcells present in the n cell. Let us come to another n cell where the principal quantum number n equal to 4. Same, suppose the room where you are sitting, that information, it is n cell where the principal quantum number equal to 4 and L residence. Same information given, just changing its cell, right? The room where you are sitting, that room called as n cell, n equal to 4, L ranges from this. So we have to find out how many subcells are present within the room where you are sitting, right? So by putting this 4, we will get the value of L. So L equal to 0 to dot 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 4 minus 1, that is 0 to 3. 4 minus 1 means 3. 0 to 3 means there are two digits within it, 1 and 2. So this implies L equal to 0, L equal to 1, L equal to 2, L equal to 3. So L will be 0 to 3. Right? So L0 is a code address of A subcell, is a code address of P subcell, code address of D subcell, code address of F subcell. Right? So there are 4 subcells are present within the N cells. Similarly, we'll go for the O cell. We got same answer, 5. L equal to 0 to N minus 1 means we will put 5 minus 1. It is O cell, N equal to 5, same information. So L ranges from 0 to 4. So this implies there are 4 subcells. There are 5 subcells, that is L0, L1, L2, L3 and L4. S, P, D, F and G. So like this, so number of subcell in any cell equal to its principal quantum number n, but n less than equal to 6. That we have to remember like this. So different subcells are present within this cell. First information is over. So it identifies different subcells that are present within a cell. Right? Second informations. Second information, maximum electron in any cell, any subcell this is all equal to 4L plus 2. Maximum electron in subcell, maximum electron in any subcell equal to 4L plus 2, where L stands for this azimuthal quantum number. For example, for a subcell, let it be subcell, azimuthal quantum number, maximum electron. For a subcell, azimuthal quantum number L equal to 0, maximum electron will be 4 L plus 2. So 4 into 0 plus 2, maximum electron will be 2. For P subcell, L equal to 1, azimuthal quantum number L equal to 1, maximum electron 4L plus 2. So this will be 4 into 1 plus 2. So it will be 6. D subcell, azimuthal quantum number L equal to 2, maximum electron will be 4 into 2 plus 2. So it will be 10. For F subcell, maximum electron azimuthal quantum number L equal to 3, maximum electron will be 4 into 3 plus 2, it will be 14. So A subcell can accommodate maximum electron 2, P subcell can accommodate maximum electron 6, D subcell can accommodate maximum electron 10, F subcell can accommodate maximum electron 14 and so on. Right? So we can, by knowing the azimuthal quantum number, we can calculate the maximum electron present in any subcell. Third information. third information, the angular momentum of any orbital, angular momentum of any orbital equal to h whole into h by 2 pi whole into L whole into L plus 1. H by 2 pi whole into L plus 1 or root. Right? L whole into L plus 1 whole into H by 2 pi root of this. So angular momentum of any orbital, it is a integral multiple of H by 2 pi whole into L whole into L plus 1 root. So our L stands for azimuthal quantum number. By knowing this azimuthal quantum, suppose you have to calculate this azimuthal angular momentum of p orbitals, s orbital, or any orbital. So you have to put the value of L only here, right? Fourth significance number 4. The radial node or angular node, both we can calculate. The radial node of any orbital equal to n minus L minus 1, where L stands for this azimuthal quantum number. For example, we have to calculate, let the radial node of s orbitals. For example, for s orbital, for 2s orbital, let it be for 2s orbital. So for 2s orbital, n equal to 2. For s, it is n equal to, for s, L equal to 0 minus 1. So the radial node will be 1. For 3p orbitals, so n equal to 3. For p, L equal to 1 minus 1. So it will be 1. Like this, we have to calculate the any node of radial node of any orbital. Angular node. Significance number 5. Angular node. Significance number 5. We'll discuss regarding angular node. Angular node of any orbital equal to L. Just its azimuthal value of azimuthal quantum number. So these are the all information regarding this azimuthal quantum number. This azimuthal quantum number is finished. Or before we finish, just you have to remember. Suppose this is fast cell. Suppose this is K cell. Right, but the principal quantum number n equal to 1, subcell will be 1, that is S subcell. For the, let it be for this L cell, but the azimuthal quantum number n equal to subcell will be 2, that is S and P subcell. For this third cell, for N cell, principal quantum number n equal to 3, subcell will be 3, that is S, P and D. For fourth cell, or it is N cell, where the principal quantum number equal to 4, subcell will be 4, that is S, P, D and F. For the O cell, where the principal quantum number n equal to 5, it will be S, P, D, F and G. Right? Maximum electron that also accommodated in a subcell will be 2, it will be 6, in D subcell it will be 10, F subcell it will be 14. So in G subcell it will be 18. Right? So also we can calculate electron also in the same way, S2. So A cell also contain maximum electron 2. S2 and P6 in the second cell are the n equal to. So S subcell contain 2 electron, P subcell contain 6 electrons. So total electron in the S and P it will be 8. So maximum electron present in N subcell will be 8. Come to the third cell, N cell. For the subcell will be 3. S, P and D. S contain 2 electron, P contain 6 electron, D contain 10 electron. So total electron in third cell S plus P plus D it will be 18 electron. Like this, S2, P6, D10, F14 it will be 32 electron. So anyway you can understand it. So Azimuthal quantum number is finished. So any problem you just give me by the message, right?
Do like, share and subscribe.